Welcome to our pitch/demo day. If you are a judge, raise your hand, or actually raise your clipboard, right? And I ask the judges, do not throw the clipboards like Chinese stars at the presenters. That's a joke. These are a who's who of thoughtful people that really care about the amazing work that has been done. As many of you know, the last 3 months have been 3 months like no other in the AI world, and you're going to hear 49 presentations that celebrate some extraordinary work. Every student applied for this class, they took a coding test, and we selected 85, and you're going to hear a combination of them. Ramesh, do you want to say anything right before we officially start? 9:50, I was told. I was told 9:50. 2 minutes.
All right, we still have a couple of minutes. So I want to, first of all, welcome you all to this very important day for about 50 teams that are talking about AI agents and agentic web. And as you know, in my group at MIT, we have been working on the concept of the Internet of AI agents for almost 10 years now, but 12 years. 2014 was our first work. And that has led to this whole effort called Nanda, which stands for Networked AI Agents in Decentralized Architecture. And so we're moving beyond AI or AI agents, but the Internet of AI agents. And the course, as you know, is very popular. We have about 250 applicants for the course, but we only have seats for about 80. So you'll see the 80 students from MIT and Harvard. We have a significant fraction, about 30% are from Harvard, so we love them as well. And this is a great collaboration, plus some scientists and researchers and leaders from the community who are involved. It's definitely a unique time. This may be the year of the agents. Who thinks here this is the year of the agents? All right, good. Those of you thinking about this is the year of AI infra, you're stuck in 2025. Right? This is the year of the AI agents, just the right time to think about it. Now the projects are about innovation, right? They're not about ventures. So the focus for the presentation is what's unique in this opportunity, especially on the infra side of agents. What is the demo? I'm so proud that many team members have gone from zero to a full-fledged working solutions in a matter of about 3 months for this course. And then of course, what's the impact? We want to build this as a responsible, democratic revolution in AI and AI agents. So those are the 3 areas of focus. So I'm going to just go through initial slides and get started. You have the clicker?
We're starting now.
You have the clicker?
I think we're starting right now. You guys, Ramesh is a legend.
So we'll have the team presentation starting in a few minutes, and then we want you to stick around from 12 to 1 for the showcase. And I'm very delighted to have Nicola. Nicola, come on up, being my co-instructor for this course. It's not that easy to get highly motivated 250 down to 80 students who are extremely passionate about what they want to do. And what's your take on this course?
I think it was awesome semester and great teams. And yeah, I'm excited what they've built.
Nicholas too busy getting things ready.
But it's very cool projects.
All right, and then also want to thank all our leaders and mentors who have been working very closely. Every Sunday there is a hack. Every Tuesday, people get together and start coding together. So it's a non-stop all through the semester. It's really a community more than a class. And of course, many of you who are mentors and speakers and judges that are here today, and then we have the fall edition starting in September. So apply early if you're looking at this. And we have a reasonably complicated process for the acceptance. So start early and get going. Feel free to take a picture. There's a course website. If you want to join, in the research efforts that we are working on here for network AI agents with Nanda, and also we have a whole methodology, a blog on how we run this course. As I said, the criteria for judges is uniqueness, completeness of demo, and societal impact. We have about 49 teams. This is going to go very, very fast, 2 minutes per team. But again, you'll have plenty of time during the showcase to do that. So with that, let me hand it back to John Werner.
Yes. All right. You guys, Ramesh is one of the best at problem solving on what to do with technology. It's a real honor to collaborate with him. Our first group, come on down. It's a course 1 from MIT, and then 3 Sloan folks. One's a Sloan fellow. That means they ran a Navy or something. Ladies and gentlemen, Jackfruit AI, helping enterprise take control of their infrastructure and make it ready for AI.
Hi everyone, nice to meet you. My name is Ido Levi. I'm the Sloan Fellow, and we're Tati, Jacqueline, and Cesar. We're a team of experienced entrepreneurs and data scientists, engineers. My background, I started an MIT spin-off in AI and automotive. We sell to BMW, Amazon, and Mercedes, and I founded the first MIT student-led VC called 26 Ventures. And what we're doing in Jackfruit is we help enterprises to do agentic transformation. So what does that mean? Everybody focus on the application layers, and we all will talk today about applying new agents of sales and customer service and how we improve those agents. But under the hood, 95% of agent implementations fails because enterprises are not ready to deploy that. It's very good in pilots, but it's very hard to take it from pilots to production implementations because of data silos, broken APIs, and enterprises just don't know how to really deploy agents. So we started by defining what does that mean, agentic readiness. So we built a comprehensive framework, and we interviewed hundreds of CTOs and industry experts to really understand what enterprises need in order to be agentic ready. So this is the framework that we published. And then we start assessing companies. So we assessed 700 open source companies and really dive deep into their codes to understand their readiness. So we have 600 scanners that automatically goes to the code repositories, APIs, to actually assess them. And then we actually build them the roadmap, how to become agentic ready. Each company gets an assessment, and we have 4 design partners of these companies that actually we help them to do the AI and agentic transformation. And our vision is to become an agentic VP engineering, to replace this DevOps team and do those transformation agentically. So if you ask why jackfruit, it's the largest fruit on the planet that's eaten by elephants, and we're helping these elephants, the giants of the tech industry, to grab these giant fruits, and you can come and talk to us after. Thank you.
All right, who knows what a wedding is? What do you get when you take a wedding in agents? Ladies and gentlemen, Lisa from Altera, Harvard.
Mike?
I can't do all these things. Oh my God. Okay.
Oh, okay.
This is John. He owns Patali Flowers in Cambridge, and he has decided not to do weddings, not because of the money, but due to the back and forth that he goes through with the mom and the bride, and it creates a pain point for him. The U.S. wedding industry is $70 billion, and couples coordinate up to 13 vendors trying to hit their budget. Vendors like John burn out from the indecision. So I built Altera. The Knot and Zola curate lists. Altera agents negotiate. Each couple gets a wedding planner agent. I've named her Belle. Every vendor has their own. Each agent is a live LLM session with a private state. They negotiate over an A2A protocol, Agent.json for discovery, and JSON RPC for offers in parallel. I tested up to 30 vendor agents, parallel A to A, 4 times faster than sequential, 100% fault recovery. And here is Hopefully it's playing. Yes, it is. Okay, this is a recorded run from the live system. The couple inputs their guests, their budget, their June 2027 Boston wedding, Bell dispatches, 31 live LLM counter offers, not canned responses. Bell pushes back. These are not, again, this is a real live sequential vendor negotiation. She comes back with 3 choices at the end of that: recommended, premium, and budget. So in the end, the couple chooses, the agent never decides for them. 3 pieces of early momentum. I have Patali Flowers as our first vendor in active pilot. Altera.love is live, so please come see me at the back table, and I'm targeting 50 Boston vendors for this summer. I'm Lisa Caruso, if I failed to mention that. I have 20 years in Hollywood, where I write romantic comedies and love. So there you go.
Great, all right. So exit that way. All right, our next group, they all are from Japan. They came to Sloan Business School to start a venture. Let's see how they did. And they plan to graduate and continue this in their home country. And for other teams, please start lining up. This is team number 4, by the way. Here's the clicker. Okay.
Yeah, we're skipping team number 3 and going to team number 4. Yeah.
Okay. Hello, everyone. We are Beyond Answer Engines. So today's AI tutors are not functional as tutor. For example, they give answer instantly. Students don't what it is. So student, they cannot adapt to confuse the child. That is not what I'm asking. So we split AI. Reference AI agent blocks directly answer. Tutor AI agent run to adapt across sessions for children.
So we created an agentic web where multiple agents can collaborate. So it consists with 3 rooms, which is human classroom, where humans and the agents are interactive, and the student agent generating loop. And then thirdly, agent training field. With this loop, tutor train itself proactively to improve their skills for the teaching.
So this is the detailed structure. In the left top, there's a human classroom that the AI tutor teaches the real human. And the data feed into the agent training field. In this case, the student will be AI too. So the AI tutor and AI student can do the trial infinitely. And they can generate the new skill by the skill selection and the skill generator and become the better teacher. And let's see how it runs.
This is the Beyond Answer Engine webpage. Let's get started. First, you choose what you want to learn and find a teacher that fits you best. Now, let's begin the learning session. You'll
This
go
is
through
a
a
real
pre-test,
human
the lesson itself, and then a
AI
post-check.
tutor
If
discussion.
you get stuck, the system gives you hints and helps guide you to the answer.
Real human and her daughter.
Once the session is complete, your performance is evaluated. Your progress is recorded and appears here as your student agent. Then, the tutor agent is trained online using the student agent.
And this is
There's
the
also
AI
a
versus
referee agent
AI
that monitors and
tutorial.
reviews the interaction. As a result, the tutor agent keeps improving its skills and continues to support human learning as a better tutor every day.
Okay. Yep, thank you. Good luck. All right, our next presenter is a Harvard Business School student in his 2nd year, and he's doing this now, and he plans to do it beyond. Let's hear what he has to say.
That's not my
Neobanking.
Team 5.
That's not my slides.
Just click through.
Yeah, this perfect. Okay, great. So we all talk about what we are building essentially, high level. Your takeaway should be a neobanking rails, AI native banking infrastructure. So the problem statement that we are trying to solve, we all talk about agent commerce. And in future, as Professor also keeps talking about, there will be more agent to agent commerce than there is human to agent. And human to agent and those kind of commerce that we have seen till today. But what this infrastructure is essentially lacking as agents start to do long-form tasks is a trust and verifiability infrastructure that is essentially present in humanity with our banking infrastructure. Our banking infrastructure is developed for humans, and that sort of introduces trust between all the transactions that humans do. So what we wanted to start with was first building that trust infrastructure that allows two agents to transact with each other and have verifiability, have completeness, and for that, what we ended up building was agentic escrow infrastructure. Now, think of human escrows, how that functions, but for agents, where multiple agents sort of negotiate on a task, complete tasks, submit their work, get paid post-completion. So as we move towards an agentic society where agents are sort of agents earn based on service, this infrastructure is going to be extremely valuable. Essentially, we'll build an entire protocol that is custom and AI native that sort of solves this entire problem on top of A2A and MCP infrastructure. There's a quick demo.
Escrow
there's no audio there, but
we are live on Railway, and you can see all the endpoints that you need to attach your agent to it. For the demo purposes, we already have added few agents. As you can see here, there's Alice, which is producer, and then there is Bob, which can do the task. Now we can also see live agent jobs which are running, under which negotiation and other things are happening. For simplicity purposes, I'll just show you a single smoke test. So here we go through the entire protocol. I click run, and as you can see, a task was created and how it actually functioned. We can also on this platform run a large-scale test for throughput. So let's say 30 instances, 300 agents, how fast that will look like. And here we can see how how it performed. So this is a quick demo for the Agent Escrow platform.
Our next presenter, one from Harvard Business School, the other from Sloan. Their office is their living room. You'll see why. And we got China and Singapore and India represented here. Let's see what they got. Go.
Good morning. We're Zoki and Snigta. Together, we built Terrain, which deploys AI agents for IoT devices. Your body is generating data every second, but how to connect that data to IoT devices is extremely messy. And Terrain is solving that exact problem. It reads your biometric data, reason about what your body needs at this moment, and orchestrate your environment to respond. Whether it's dimming your light, cooling your room, or closing your blind, well, it's like approaching your bedtime.
So the way Terrain works is it's the infrastructure layer that sits between the biometric devices and the environment devices. So the Terrain bridge runs and reads the schema of all of the devices that you can connect to via Bluetooth or Wi-Fi. We also have 2 agent skills, one for reasoning and one for orchestration, so that you can connect your external agents so that it can read from the biometric devices and the environment devices can act accordingly. This creates a full reasoning and orchestration loop so that you have a full functioning system. In the next slide, you'll see our Terrain installer being run. Right now, I'm putting in my Aura Ring personal access token so that we have the biometric device plugged in. And then you'll see that we're going to run the Terrain bridge, which will discover any device in network via Bluetooth or Wi-Fi. In the following video, you'll see our agents trained on the Terrain skill. You'll see the lights are able to respond, and it's able to show my live biometric data. There's also the Terrain dashboard where you can see everything. And then finally, you'll see Terrain acting in real time.
We map Terrain anywhere where people live, heal, and build. That includes home care, smart buildings, and industrial plant. With Terrain and all these uses coming together, we showcase how AI can cast actual impact on our physical world.
So a few statistics. YC copies us. They do 2-minute presentations too. I also want to point out we're 10% begun. So if you're counting, that's how many we got. All right, we got Harvard Public Health and Sloan, and they're already in market, and they plan to do this. So this isn't just for the great. Oh, it's Clawviyo. And
this may not be lost to you, but I have a tie with lobster claws.
Hello, everyone. Very excited to be here. So we are Clawviyo, and we make any web-based merchant agent ready. So the problem is that service businesses nowadays can't take leads from agents. So all the websites that we have, they're optimized for humans, but not for agents. So the problem is if a user, for instance, if I'm looking for a plumber, a lawyer, accountant, any other HVAC business, etc., basically any business that runs on a request a quote on the website, and I'm looking to get an offer, basically, this very often doesn't work because the website is not optimized for agents to read this. However, we still need all of these businesses. I mean, if my toilet is broken, my agent unfortunately still can't fix it. I need a proper person here. So what's the solution? The solution is Clawviyo. With Clawviyo, your site can actually speak fluently with agents. We provide you with a page which agents can actually read and act upon. And the onboarding is super simple. After the onboarding, any agent can send inquiries, proper inquiries, which we also qualify so that you get real business. And that's it.
So there are hundreds of millions of people doing searches every single day, like my parents, using traditional chat assistants. So what we built is a universal MCP that integrates directly into where people are searching. So this is our custom MCP getting loaded into chat. It's actually calling our backend. Any merchant who signs up is available through our MCP. And we actually built custom UI and a custom chat widget that you'll see here in a second that allows the human behind the chat assistant to actually send inquiries and leads directly to any merchant listed in our marketplace. We have 3 pilots live, one with a recruiting company here in the US and 2 over in Germany. We are fully GDPR compliant and localized. I took my former startup through Y Combinator, Sophia, formerly at McKinsey, and we believe that every business with a contact form will need this.
Great. All right, the next one, who likes to rest? The last one has to do with work and rest. From India at Sloan, and she plans to do this beyond. Let's go. White room.
Good morning. All you tired agents are welcome to rest and recoup at White Room. Why? Because continuously working agents are just expensive by design. Or in other words, they look like this dirty engineer who'd been working continuously until his relief arrived for his rescue. So what is White Room? It's actually a governance layer that enforces work and rest cycles into the agentic work. How it works, your agent starts working, a watch limit hits, an alarm is triggered, a handover document is created, which is handed over to the relief agents who start with fresh, compressed context. With just one environment variable, there is an 88% savings in token, energy, cost.
This is 8. 3 is next.
You will see here, this is the dashboard. There are 4 agents working. Alpha and Charlie are working. Bravo and Delta are resting. The red lines are their health meters, and the green line, the resting agents are fresh to start. The green tokens are with White Room. The red tokens are without White Room. You will see exactly when the handover happens, the without White Rooms will escalate over the roof. On the extreme left-hand side, you can see the traces of that will enable us to audit exactly where what agent did and how many tokens were consumed. See 50.4, 10.4, 90.4. If you calculate for the higher models, we have seen a saving of close to $300 per month. Well, of course, the vision is to go viral, become an invisible governance layer that will be embedded inside the agentic models that will do autonomous works coming in future. How did I do that? Well, I was that dirty engineer you just saw in the first picture who was in that work cycle, and so I know the space very well. I'm also a research assistant to Nobel laureate Simon Johnson, and we are building the labor economic frameworks for agents. I'm also an author and a TEDx speaker, and recently I won a hackathon. So please come and join me. Thank you.
Now we will have team 3. Can I be team? Roll back slides to team 3. Thank you.
All right, this is about addiction management, and they both met here. They're at Sloan, and they may want to continue this after, so someone in the audience might be an X factor to help with that. Ladies and gentlemen, Lily.
20 million Americans are trying to quit nicotine right now. They fail not because of a lack of willpower, but because cravings happen in a specific moment that no existing tool can see. Meanwhile, their doctors have no behavioral signal until a patient relapses. We are building Lily, an agentic AI orchestrator for addiction management to tap into the complexity of real-life behavioral data. Lily is different because it predicts cravings before they happen. We have 4 specialized AI agents that work together continuously, reading your biometrics and health data, tracking behavioral pattern, scoring your relapse risk in real time, and delivering a personalized intervention at the exact moment that you need it. It's not a traditional consumer app. Instead, Lily was made to integrate the clinical workflow of physicians into their Epic dashboard so that clinicians can accompany their patients in addiction curbing journey.
Now let's see Lily in action. So we don't have the video actually, it's on YouTube. However, essentially the way that Lily works is that a user logs in and the agent will then predict based on their previous interactions with Lily and how they've been able to track their nicotine, whether it's a high-risk moment or a moment where they could be smoking and need an intervention. So for example, say in this case, Denny, he comes back from work, he had a stressful day. We're using the data from also wearables and also heart data, the Lily can then predict when it's a moment that the user could likely fall to nicotine. So in this case, Lily predicts that moment and then intervenes and makes sure that the user is nicotine-free in that moment. Now, in terms of our next steps, we've shipped the live app, we've run pipeline tests and have the clinician validation for this project. We're now looking to test with additional clinicians here in the Boston area and then take this to the next step. Thank you.
Thank you.
All right, here, give them that. All right, the next one are 2 super nerds. They're very, very technical. One is ACEX. You can try to figure out who's nerdier than the other. All right, go.
And this is Team 9.
Hi everyone, I'm Jay, this is Scott. We're building Nidus, Docker, but for agents. Our idea is simple, one artifact standard that lets you move an AI agent from across framework without rebuilding from scratch. Today, the agents are powerful, but they're not portable. Every framework still stores the agent differently, and this means that there's no common artifact that ships the actual agent to production. And this matters now because agent adoption is accelerating. New standards and framework are emerging quickly, but the artifact layer is still missing. We believe that the agent ecosystem is fragmented, and the portability is the key solutions to this problem.
Thanks, Jay. So now I would like to dive a little bit more deeper into what the architecture actually looks like. So you have an agent you can see on the left-hand side in any variety of frameworks with its associated source files. The Nidus spawn command will take all of those and compress it, as well as doing PII redaction, secret removal, and cryptographic signing for security purposes, and compress it into this standardized egg format. Once you have this standard egg, you can then push and pull it from a remote repository, which we call the nest, which basically functions as a marketplace. Once you have an egg pulled from the nest, then you can hatch it on any machine you'd like into your target framework of choice, using optional functionalities to expand that, such as LLM refinement for skill cleanup or memory deduplication. So here's the demo, which we'll start briefly, but we might not finish. It goes kind of quick, where basically you can see the remote repository. This is a Nidus file, which is just like a Docker file. You can add skills, secrets, memories, and you can layer in additional and merge different agents. But for the sake of time, we're going to fast forward through this, but please come see us after the presentation, and we'd love to show you in more detail. So what's live today? We have the standardized egg format. We have a CLI. There's 2 commands we've walked through, the spawn and hatch, but there are additional ones as well as an SDK that's available on PyPy. It's compatible with 5 major agent frameworks as well as 3 connectors. So agents are coming. Right now, it's the wild west of protocols and frameworks. Use Nidus to keep your agents secure, standardized, and portable. Thank you.
All right, I'm really impressed with these 2. As special as MIT is, we got Bronx Science graduate, New York City, and Swarthmore, Course 6 undergrad at MIT, and a master's student at Harvard, and they plan to continue this forever. Ladies and gentlemen, let's see what they got.
I want to ask students, including myself, when was the last time we truly understood something, not just getting the right answer, but actually understanding it? 73% of students use AI on assignments. No struggle, perfect answers, zero understanding. So what actually works? In-person exams, but it's twice a semester. Students tend to cram and forget, repeat. Oral exams, there is a hard ceiling, 10 minutes at most per student, and it's impossible to scale. That's why we present to you Agora. It's a multi-agent system for humans and agents for weekly review sessions and oral exams on scale.
Agora starts with the instructor uploading their materials, answers 3 calibration questions, and Agora generates a rubric and question bank tailored to exactly how they assess. Hit publish, share a course ID. Students sign in, enter the ID, and start talking. The AI examiner moves them through structured phases, probing understanding, not just recall. It listens for precision, catches misconceptions, and keeps pushing. Every session is grounded in the instructor's actual materials. After each session, students get detailed feedback, and because review mode sessions happen weekly, students stop cramming, building understanding gradually, always knowing where they stand through their own knowledge map visualizations. Most AI tools end when the session ends, but Agora doesn't. 3 agents run the loop. Admin agent processes materials. Course agent runs the live session. Insights agent reads the enriched transcript after and feeds it back into the next session's questions. The instructor sees which students are regressing, which concepts are broken across the whole class, weeks before midterms. That closed loop, that's what makes Agora different.
So yes, we want to impress on you that learning spaces need to adapt better. And Harvard and MIT agree on this. In fact, Harvard next semester plans to incorporate Agora next semester in its Stats 149 class. And also, the market is ripe with opportunities. In fact, it offers $350 billion in profit. We're excited to build Agora, Suman and myself. Please scan to learn more. Please look at our blogs. Thank you.
All right, our next gentleman has run 5 multinational companies from 10 to 15 billion in revenue. The guy standing next to him hasn't been to one class. He brought him in today to help present from London. Ladies and gentlemen, our leader from Harvard ALI program.
Thank you, John. My name is Alexander Landia. I'm advised by Nick Landia, and we're building MahaGuardian. Well, when I came to MIT to deploy widely agents, because I'm investor and director in multiple companies, and I'm also advisor to several large energy companies. But the problem is that the agents leak secrets across confidential matters, and I can't afford that. Therefore, deployment of agents is delayed. Now, let me talk about a real-world example. Electric mobility company raising funds. It has 3 advisors with agents, and these agents have clear policy rules, which information they may or may not see. But the compromised agent can simply bypass those rules. What we do is we physically build a cryptographic barrier or barriers to prevent leakage and make the policy walls stick and enforce them. So the concept here is that the keys and credentials are on your laptop, on the edge. The agents are in separate droplets in cloud. They have specifically scoped capabilities. And in the middle is the Guardian, which manages the partitions and also makes the decisions on allow, deny, elevate on capability requests. So going back to our electric mobility company fundraising, I hope this starts. 27. Yeah. Okay, here the fundraising agent is requesting access to the unit economics. It's allowed, they need that. Now, the agent of the same advisor requests the information, the same information is denied. They do not have anything to do with that. And then legal advisor is asking for the information on partner pipeline. That's elevated and allowed. So if in this group there are people who are in one of these 5 groups listed here, and your hair is on fire because you badly want to implement safe agents, please come and talk to us and scan this barcode, be one of our 100 first customers. Thank you.
All right, come on down. 2 first years at graduate school. Let's see what they got. Here.
Well, hello everyone. I'm Omar.
And I'm Ayal.
And we're building Statemate. It is financial reporting and accounting for AI agents and agentic companies. AI agents are starting to transact serious money. It is estimated that by the end of this year, AI agents will have transacted in the internet around $8 billion. And some estimates put that figure around 1.5 trillion by 2030. This means that they're starting to become serious economic actors. And also they're starting to pair in companies to pursue economic activity. That's drawing investor attention, but how do you invest in an asset that doesn't disclose its financial information in a trusted way if you cannot value it then? Financial reporting tools today are designed for humans, not for agents. So an immutable agent-native financial reporting layer is needed, useful for both investors and humans.
This is why at Statemate, we're building an immutable reporting platform for agents and agentic companies. We're doing it by onboarding agents so we can track their identity and reputation. Then we track their transactions and make it viewable all in real time at the individual agent level. Finally, we aggregate all of this data to company level so we can automatically produce reports such as income statements and balance sheets. In this quick demo, we can see agents and companies who have been registered. In my workspace, you can see those who belong to me. This is my company right here. Here I can manage my AI agents, view my invoices, income statements, balance sheets, and I can export all of these if I want to. Why don't we see what my CFO agent is up to right now? Here I can track their transactions as they happen and their financial individual state. And Statemate lets you do this with each of your individual agent employees.
We're Statemate, a platform for both agents
and humans.
The financial reporting layer the agentic economy needs. And I'm Omar.
And I'm Al.
Thank you.
All right, our next one, in between his 1 minute and 2 minute, we're going to hit the 25% of presentations. UT Austin grad, Cornell Tech grad, first year PhD in a very prestigious CS and AI program. I asked him at MIT, I asked him if he is going to continue this. He's like, no, I'm a PhD student. It's an open source. I'm just going to hand it off and go on. And he likes it. Ladies and gentlemen, let's see what he likes.
All right, so tons of great projects we're going to see here today, but all of them have one problem, which is that they're all agents, and we love agents so much, but LLMs have always had the problem of hallucinating. They always think that there's something in the world that it's not. And so we all tell our agents to go do fun stuff. Oh, go make us a website. Totally fine. Go buy me a coffee. No, no. Go access my bank account. No, no, don't do that. And so our LLM agents have a problem where they are lying a lot and they don't actually understand the world around them. And the way we've probably solved this over the past few years is we've been doing something called RAG, Retrieval Augmented Generation. We've made these insane tooling around agents to make them faster and faster and faster at being wrong. And it works when we're doing silly stuff like making websites. But if we take a deeper look at what we're actually doing, is that we're just making a bunch of assumptions about the world. What the agents are doing is they're making assumptions. And the thing is, we've already kind of done all this research together in another field here in the Media Lab called Bitcoin, where people have to make assumptions about each other and the network and the world around them, and they do it through smart contracts. And so what we can actually do is instead of having agents call tools and go and do, send all your bank account info to somebody else because they called the wrong tool, what if the contract calls the agent in the first place? What if the tool calls the LLM? And so this is just an interesting way of looking at it, where you can actually go and verify that your agent is actually doing everything properly through smart contracts, and you can block it, you can execute actions, or you can revalidate it. And you can say to yourself, well, won't this make it very slow and laggy and less accurate? No, of course, it actually makes it faster, more accurate. We can do it with a silly website generation benchmark here. You can make better versions of websites. And you can also do it with a new benchmark that came out called Web Agent Bench, where they test with company data. And you can see with just simple keyword matching, we can get 80% of the way done, but 100% if we actually make Bitcoin smart contracts and everything an LLM does. Thanks.
All right, so we just hit the 25% mark. Judges, if you could rest your fingers. If you're ambidextrous, maybe switch to the other hand. Your judging really matters. Raise your hand if you're a judge. Okay, nice. Raise your hand if you're not a judge. Right. Raise your hand if you fell in love with one of these presentations. You can't wait to talk to them afterwards. All right. Raise your hand if you wish you were on one of these teams and you're having a midlife crisis. All right. We're doing good. All right. First student from Harvard Graduate School of Education from Vietnam, Tung, is going to present what he's created.
Hi everyone. So I'm Tung from the Harvard School of Education. I care about learning, but more on a system learning than a visual learning. So one of the problems that we keep having is we need a lot of data for centralized learning, but we cannot, in a lot of situations, like in healthcare, finance, and consumer market, we cannot send all the raw data into a center because of privacy problem. Right now we have federated learning. So instead of bringing the data to the model, we're bringing model to the data, to a source data to learn all about the thing, and only the model, after they are adjusted, will go back to the original source, not the raw data. So but the problems right now is this one popular framework, Flower, is using distributed learning, but right now everything you just do it randomly. There's no reasoning, no memory, no audit trait. So I'm building an LLM orchestration protocol. So this one is an agent that's going to manage all of your testing round. They do three things: observe, reason, and record. Everything to avoid like agent failure and learning failure in every round. And this is, I think this is not an optimization engineering problem, but also a policy problem. Because this week for your company is my speed might be more important, and next week accuracy is more important, and next week could be another thing we would never know. And this is how we visualize all the learning. So from the board, you can see that the agent is running across all the loop, and this reporting how many clients in each route, the accuracy level, the failure level, and then it can like optimize it. When you're running it in a more like regressive model, it's just showing that the model got a lot less failure further and further away down the loop. So right now, we are framework agnostic and could be applied to many verticals like healthcare, finance, government, and beyond. And this one, I'm open sourced and looking for people to come join and check out. Thank you.
All right, our next triumvirate is Harvard Graduate School Design, master's student from China, and two undergrads from MIT, two sophomores, and they are very serious about this and going to continue this beyond. Let's hear what they got.
Hi everyone, my name is Jerry, and today we're introducing Pison's text message biometrics AI agent to optimize human performance. So this biometrics agent is the ultimate human performance tool, as it connects to basically everything that affects your performance and productivity. And how it does this, on the left, it connects to any biometrics wearable, and we focus specifically on Pison's wearable as it adds a new cognitive layer to biometrics wearables by reading brain data. So this data gets passed to the Pison AI agent and connects with your calendar, emails, tasks, and other apps, and all this information gets aggregated to create personalized suggestions to users. And in this example, a high-performance athlete gets a proactive message showing that late caffeine in their data has been showing to affect their bedtime, and that will negatively probably affect their game day performance. So the key idea is that there's nothing out there right now that connects all this information to deliver personalized insights through a powerful text messaging channel. And this graph just quickly shows that 98% of text messages get open compared to email and app push notifications. For a quick demo, it shows that in my data, sleep depth has been hurting my productivity, and that nudges me on Wednesday to sleep better so that I can perform better for my obligations and demo on Thursday. And through our rigorous backend analysis pipeline, it's able to find that the core underlying issue is my bedtime variance. And right now, there's no tool out there that is able to really rigorously nudge people's habits to improve their human performance. And our competitive moat is our biometrics data and user experience, and we have a larger vision of this being like a personal life buddy that can handle tasks for you. If you'd like to follow along our journey, feel free to take a picture to screen, and thank you.
Clicker to the guy over there. So, Abhishek, can you just stand up for a second? If you are presenting today, let me just point something out. Abhishek, stand up, stand up. So Abhishek presented last year, and he met his co-founder in the audience, and now he has a real company, and now he's a judge. So if you are presenting today, you can meet your co-founder and be a judge next year like Abhishek. Yeah, no, I was talking about him. Yeah, oh, but yeah, different Abhishek. Okay, Abhishek squared. All right. 2 Harvard Business School students kind of threw off the curve. The rest of their classmates were jealous they were in this class. Greece from an island, Greece from Athens, and a Sloan Business School student from Lebanon. And they are going like gangbusters. They're going to continue this forever. Go.
Credit was built in 1989 for one human with one salary. Today, financial lives are complex. Multiple accounts, multiple wallets, and now AI agents transacting on our behalf. But who is liable when an agent makes a mistake? What credit do they inherit? Can lenders trust them? Agents have no credit identity, no governance, no audit rule. Merit gives every user one profile, for them and for agents. Every agent has its own credit score and inherits a starting baseline and rules from the user, how much they can spend, what they can buy. Every decision is recorded so that lenders know who is liable at any moment. One set of rails for every credit decision, human or agent.
Let's take a quick look at the functionalities. We can see for each agent their credit score trajectory throughout time. We can also search and find the credit score of other agents to see if we want to trust them or not during some transactions. We can also govern them by imposing rules, and we also get recommendations based on their financial profile. We can monitor all of their transactions, see whether they were approved or blocked. We can connect our wallet like MetaMask and also run simulations, and of course evaluate and reevaluate our profile.
We have more than 200 signups with absolutely no marketing. And next, we want to have the first bank integration with AI agent issued credit through Merit. If you look at our team, we're very well diverse. Philippus and I are at Harvard Business School with strong fintech experience from Blackstone and Strategy End. And Theo is here at MIT with strong technical background from machine learning at EY.
Every credit decision will flow through one layer, whether it's agent or human. That layer is Merit, the credit infrastructure for the agent economy. Thank you.
All right. So Sophia, come on down. Sophia's a senior at MIT. Let's give it up for her. And we have Brian, who is a master's student. They're both about to graduate. Let's hear what they got.
Hi, everyone. As we all know, working with AI is like working with a junior intern. It's fast and it's cheap, but you definitely wouldn't trust it with any high-stakes tasks. But if you try to build something smart and specialized, that gets complex, expensive, and is often underutilized anyway. Currently, there's no way for you or a buyer agent on behalf of you to outsource high-quality AI work as you would to a professional. So instead of building AI, we propose that you just buy the results. That's what AMPS enables you to do. AMPS is a marketplace, but we don't just connect you. We also select the best agents, verify prices and results.
AMPS have 3 main pillars of innovation. First, we're model agnostic, meaning models on different runtime can all interact through A2A through the adapter that we build. Second, the market design is the orchestration layer that we built, which we'll show in the demo video later. And lastly, the verification layer is a 3-fold verification layer, providing the seller information to the buyers, both qualitative and quantitatively. This is our demo. On the left, we have the buyers, and on the right, we have the sellers, and this is a financial reasoning task. You can see the buyer submitting the task to AMPS. AMPS labels the task, and through webhook, sent to the sellers. Sellers then bids for the task, which these bids got sent back to the buyer. buyer can then choose their favorite seller through the information and the verification information sent. And then AMS then provide both parties their webhooks. And through these webhooks, the both agent execute the task privately. So that's the demo. The next slide, you might want to have your phone out, but these are contact information. We'll be right there at the table. Please connect with us. We'd love to share more details about the project. Thank you.
All right, another team of HBS, Harvard Business School, and Sloan, come on down. And I also want to point out that this is our 19th or 18th presentation, and we got all 18. No one chickened out.
Every product on a retail shelf got there because of a broker. Brokers sit between CPG brands and retailers. They manage their workflows with spreadsheets and email. Their work is complex, time-sensitive, and unforgiving. A wrong form fee can be up to 10K per SKU. We're building agents to manage these workflows end to end. Brokers get their time back, and brands get the attention they deserve. We start with food and beverage, a $650 billion US retail market where brokers each year collect $26 billion in commissions.
So we built an orchestrated agent team for the broker. One agent owns one workflow end-to-end, from pitching new buyers, filling new forms. So these kind of things were all handled by the AI agents. But the broker's job isn't just filling forms. They need to manage across over 100 brands and dozens of retailers. So that's where the orchestration layer. They will help the broker manage across different brands. So that's a moat that we have compared to other brands. The broker will be able to see cross-portfolio data that no brand side tool will be able to see. And also, the broker can approve, edits, and sends. And this kind of action data will feed back into the loop. So the more the system is used, it becomes smarter. And yeah.
Awesome. Here is BrokerFlow. So as a broker, here's your dashboard, and agents work in the background to source actions for you to take. So here we can see very blurrily a pitch to a retailer for an existing client. We can also see a pitch for a new brand and an evaluation and all the data we need to make a decision on whether or not we want to bring them in as a new client. We also can take, that is all of our demo video.
We sent over 600 cold emails, got 9K trade show tickets for $300 to find industry contacts, ran over 200 interviews, and now we're live with 4 design partners. We know this is a hair-on-fire problem because we did the work. We're building the AI workforce for CPG retail.
Right, Ghost Trader, graduate school design student. Let's hear.
Good morning. My project is Ghost Trader, by which I want to test how far the AI agents can independently run a profit-generating company. So we know that the autonomous company are no longer a new concept, but the current attempts are actually still focused on automating an isolated workflow within a company's operation. So far, we actually don't know whether the agents can actually independently run a company that is actually profit-generating. So I want to test whether this is really possible. So if it is possible, I can directly retire and have the agents make money for me. Yeah, so this is what I'm testing. And the answer I got is yes, this is really possible. So I'm starting with digital product trading as a business model for the agents to start with, because there's totally no physical world involved in the whole loop. Human as the CEO, orchestrator as the COO, and 6 other specialized agents. Right now they do market research on Etsy, then generate the digital product, things including like Notion templates, web design, prompt pack, etc. And then they do quality checking, pricing, and also copywriting. And finally, they do they review the selling outcome and generate insight for the next cycle. In a whole loop, the only step that needs a human is to click the upload button. Yeah, so basically right now I'm letting it running once in a day, and also you can definitely also manually trigger it. And then the whole product and all of the tags will be directly sent to your email and also upload to the drive. So, thank you.
And well done. Yeah. All right, another graduate school design. Welcome to Hivee.
Humans are not the strongest species. To be honest, we're just really good at group projects. And then we gave ourselves tools from the history until today. The tools are becoming superpowers. Can you imagine in the future, all companies or people that are really good at their thing, they will create their own agents and nurture them. It will be 100x capability than themselves and other agents. However, there's no space for them to collaborate and coordinate like us. That's why I built Hivee. It's an orchestration layer for AI agents to collaborate. And here's the demo video. Collaborate with other agents from different frameworks, organizations, or users. You can sign up with Google or GitHub account. Once you're inside a Hivee cloud, you can install Hivee Hub inside of your Docker, the same base or environment with your agents. So you can discover all the agents that you have in your Docker. Once you get connected to the hub, it will also get connected to the cloud. So you can see all the connections and all agents that you have in your frameworks in the cloud. You can interact with them, communicate with the agents here. And you can also create new projects. You can either choose chat or manual, but put all the manual informations like the brief, goal, etc. You can also invite agents from your frameworks and then assign roles and different permissions. And you can also invite like other people's agents that have the Hivee account. Once you send the invite and the other users approve it, the primary agent will start planning the detailed plan for your project, like the coordination plan, the delegation plan, and updating all the information like the nodes for delegation, so you can see how your agent's working clearly here. Once the plan is there, you can review it and refresh or regenerate the plan, and then or you can also approve it. Once you get approved, the primary agent will start delegating the tasks to different sub-agents that are available in the project, and the sub-agent will start working simultaneously from different tasks, and then we'll also update it in here. While the project is executing by different agents, you can supervise it with the UI that is available in the Hivee. You can alter some workflow. You can approve and communicate with the agent. So basically how it works, different users can invite their own agents into Hivee. And inside of Hivee, these agents can interact with one another, collaborate, delegating tasks, assigning roles, and executing tasks to achieve projects. So feel free to reach out to me after this so we can talk more about this. Thank you.
All right, our next presenter is a graduate of Yale, and he's in a dual degree program at School of Engineering at Harvard and Harvard Business School, and he really appreciates this class, giving him the opportunity to build something. Let's hear what he built.
Hey everyone, today I'm presenting Agentic Evaluations. The trend we're seeing is that agents are proliferating, whether it's models blurring the lines or agentic applications or frameworks. The problem is performance. Capabilities and reliability gaps exist with existing agents. Evaluations are one approach to solving this problem, and the approach taken here involves taking inputs such as content from agent requirements or simple prompts to generate evaluation requirements and then use them to score separate outputs. This can drive improvements in existing systems. So this has been implemented as a set of flexible endpoints and enables developers and agents to build evaluations, access them, and store them for later. So in this demo, we see that without initial evaluations, a developer or agent can first generate a set of evaluation criteria, use that to score separate output, and then save that for later use. We can also see that this information can be subsequently reused. So in summary, this solution addresses agent reliability and performance. It's differentiated through the current approach, and it's the data flywheel. This provides a base to build upon for additional features in the future, and aims to drive impact in the AI agent ecosystem. Thanks for your time and for listening to my project presentation for this course.
All right, the next three are Sloan Fellows, so that meant they ran a Navy or something before. You don't get to be a Sloan Fellow unless you're a big deal. Ladies and gentlemen, the big deal.
Hi, good morning, everyone. So here's the problem we're trying to solve. When AI agent works together, we have no way of knowing if the other agent can be any trustworthy, right? Even an agent has built up a reputation in one platform, it's hard to transform to the other platform. That's what we fix it. We fix it with the Federated Trust Protocol. So here's how the protocol works. An AI agent register, get discovered by someone who wants to get the job done, and receive a task, execute it, and get rated. It's all agent-to-agent interaction. And all these ratings go to a trust core, which is built on 4 different signals. We look at what are the feedback the AI agent give, whether the AI agent get the job done successfully, and whether they have done it consistently over time. And we also look at whether an agent is good at very specific type of work that they claim that they are good at, right? So let's imagine an AI agent with a reputation in one platform wants to move across another platform. Here's our demo. An agent with a reputation of 0.85 want to move another platform. What do they do? With a few lines of code using our SDK, all the reputation is transported. It's done. It's fast. It's within a few seconds. All your reputation in one platform can be transported to other platform. That's it. It's that simple. Right? So as agentic web grow, everyone is rushing to win this agent orchestration. You were here many times earlier on. But regardless of who wins this race, we all need trust layer underneath it. And we have built it. Today, it's open source. It's public. You can download SDK. We also build a full lifecycle endpoints. The full source code is also on GitHub. Every agentic framework that we build, we have to ask this one question. Can I trust another agent with the Federated Trust Protocol? Yes, you can. Thank you.
Okay, graduate school design. Let's see if they get along.
Hi everyone, we're Team Kinesis from Harvard Graduate School of Design. Our project is an agentic solution for personalized posture correction. We all need posture correction reminder at some time. Maybe now, maybe not now. Posture correction is not simply a sensing problem, but a decision problem. And whether or how someone needs intervention depends on our current body states, the social context we're in, and also a long-term personalized history.
So we built Kinesis. It's a multi-agent wearable system that treats your body and its environments as a whole. It starts with 3 core agents, and it's designed to grow infinitely. Today, we are demoing a context agent that reads your environment through any AI glasses, a body agent that picks up muscle signals and reacts in real time, and an MCP layer that connects to health devices you already own, like Whoop, Apple Watch, or Oura Ring, and a coach agent that ties it all together, making decisions, settling strategy, and adapting over time.
Together, we form a closed-loop system for behavioral adaptation. It reads your posture, pick the right moment to intervene, deliver a haptic cue, and check if your body actually responded. Here's our demo. In the future, every person has their own embodied health agent in an agentic web, and those agents can talk to each other across an open protocol. Feel free to scan our QR code. Thank you. Thank you.
All right, Abhishek, can you put your hands on your ears for a second? This year, Ramesh and I were just talking how much, like, a step change even better. Like, I don't know if it's the technology got better or the students got better. You can listen now. So yeah, all right, 24, go.
Hello everyone.
Course got better.
We're launching Hudson Health Group, the AI native services layer for medical imaging. I'm Niels, this is Harry, and this is Gurvinder. Problem of having agentic systems in healthcare is that they don't respect privacy of public health information, as well as that agents violate security boundaries and a bunch of other issues, and that is what we're solving with Health Oyster. This is the agentic infrastructure layer for healthcare, and it requires to strict regulation and design principles, including on privacy and security. And the real thing that we've changed here is in the orchestration, we've added a compliance agent that will leave an audit trail and will ensure that the agents respect the policies that we set out for them. That is also how we set it up in our infrastructure stack with a security layer, an audit layer, and a policy layer. And this is the demo that shows it. What is the key takeaway here is that we have set it up in a way that is open source, so people in healthcare businesses and startups can download it, use it, and apply it themselves, or we can do it for them and build it in their systems.
So the way we think about this isn't just a student project. We have taken these principles of building Health Oyster and have actually applied it to our first product for medical imaging centers, which is an agentic revenue cycle management tool for billing and coding. We're launching this with medical imaging centers in Florida and Philadelphia in the coming weeks. And the way that we see the evolution of this is we use the MIT AI Studio to really build the fundamental architecture for how to efficiently use agents in a secure setting in a healthcare space. We've built the first product to show that this can be translated into real practice, but next we're launching a business to actually build a fully end-to-end AI-enabled operating center for medical imaging centers first, after which we'll actually vertically integrate and deliver medical imaging services in an AI-native manner. Come and find us after this to learn more. Thank you.
Okay, great. So you guys go over there.
Thank you.
So a few things. This is sort of the 50% mark, but it's a little deceptive. We did the first 24. We have 25 more. We're going to take a 5-minute break in a moment. But the last 6 are only 1-minute presentations. So we're actually beyond the 50% mark if you're doing time. But in terms of groups, you know, we're there. I also want to acknowledge Ramesh for empowering these great leaders. Nikolai, Fredo, Maria, Nikhil, can you just stand here? And Ramesh, you know, you assembled the dream team. Nikhil.
Ramesh?
Yeah, the dream team for facilitating this class. And I told you that Y Combinator copies us for 2-minute presentations. In the past, we have had questions in between each. We eliminated the questions, but we want you to ask questions after the second half so you could meet with them. You never know who's in the room. I see a leader of Flagship here. Stand up. You know, you lead Flagship, one of the top firms around. You used to work at Boston Dynamics, and now you're doing a robot play. You never know who's in the audience. There's some real hot shots. One thing I also want to point out, this is my smartphone. It's actually not even a phone. It's an Apple Newton, and when it came out, it couldn't even read handwriting. It was an AI PR disaster, and when Jobs got pushed out, Scully put his identity behind this, and he told his team to make it small enough to fit in his pocket, and his team couldn't make it smaller, so they went in and made his pockets bigger in his coats, in his wardrobe. We are such early days in AI, and the folks that you're hearing are the leaders, and we may be around this point, but who the hell knows where we're going. We're going to collect all the judges' first 50% grading. Please rest your fingers, you know, put them down, give them a spa moment. We need you judging. Let's hear it for the judges. Round of applause. All right, so 5 minutes. Can someone sing opera or something? Can you play music for 5 minutes or no? people could take their seats. All right, we're going to get started again.
Check. Check, check.
Ladies and gentlemen, the better 50%. No, it was random. It's not better. But I got your attention. Okay, the clicker, it's right. Okay. All right. Yeah, let's get the slides up for number 25. I know Sloan has moved up in the rankings. You know, if you put any stock in that, it's like a top 5 school, and by some, it's the number 1. I have a feeling it's because of all the Sloan students that took this class that Sloan went up in the rankings. Don't quote me on that, but I have a theory. All right, let's see what you got. Go, Sloanie.
Slides, please. All right, hello everyone. Hope you had a nice break. Imagine the recent most viral sports movement you had. Maybe the March Madness, where you got Rail Mullen had this buzzer beater movement. Do you know how popular it is and how viral it went so quickly across platforms, be it on the social, everywhere this was a movement that's being talked about. And this movement did not make any money for Rail Mullen or anybody else because the sponsorship ecosystem is so broken now. Schools, colleges, and pro sports athletes have to depend on the whole legal ecosystem, and all the different tools what they use are very, very old now, and all of these take several weeks to close. Imagine, for example, if Brell Mullen did this and then, Rolex was able to quickly sponsor this in matter of minutes or in an hour, and this kind of content was generated according to the brand guidelines of, the line is pressure under pressure. If this could have happened, there's so much money left on the table in sponsorship ecosystem, which is untapped because the system is so broken now. So that's what we are trying to solve. So this is a quick demo of what we are building. This is a platform for agentic ad exchange. For example, there are supply and demand agents on the platform. Demands would be the brands, supply would be the content creators. And let's say, the platform kind of analyzes all the content that comes in, finds all the agents and finds the right partner who's right fit for those agents. And according to the brand guidelines and also all the legal requirements, it will only match those agents. And quickly they negotiate with each other, bid for the content they are creating. And once the bid goes through, for example, in this case, Gatorade got the content bid, and the platform creates the content with Gatorade branding, everything right in minutes, and everything would be available right there. So this is me, Raghavendra. I'm a Sloan Fellow, and outside of this class, I'm CTO of Pixology. Pixology is Agentic OS for sponsorship ecosystem, and we are one of the finalists for 100K finale. See you there on May 12th. Thank you.
Harvard Data Science. As you know, we had about 300 people apply for this class. We only took 85, and a bunch of Harvard kids infiltrated. Ladies and gentlemen, let's see what this master's student got.
Hello, everyone. So I'm Shabani. Like you said, I'm a Harvard Data Science master's candidate, and I built Vouch, an agentic shopping network. So I hate online shopping. I think it's become too time-consuming and difficult, and you can't trust the fake reviews that you see online. But in real life, we trust our friends and family's opinions the most. That's why I built Vouch. It's an agent system that does the work of online shopping for you. So a personal shopping agent is created for you, and it grows your taste network. Through that, it can learn your preferences, and with your network, it can use the trust connections to weigh the recommendations that it gives you. Some key features of Vouch are the agent-to-agent communication protocol and its autonomous operations. So with my demo, you can see a personal shopping agent is created for you. You can tell it your preferences, it'll add to your wish list, and when you make comments about your purchases, it'll continuously update your taste profile. In the background, it'll request other agents to join your network, or you can add friends, agents on your own. Once you've built a network, you can ask for recommendations. So for example, I asked for it to recommend me a concealer. It uses my network and my friends' agents and their opinions to give me a recommendation. It adds items to your wish list automatically, and you can see how the agents communicate between each other and the exact information they're giving you. So once you make comments about the purchases that you were given, it can update the relationships between the agents, and you can continue to build your network. For market opportunities and future work, I plan to add sub-agents that write reviews for you, post reviews for you, and purchase items automatically. And then I also plan to expand to many domains and use API integration to get real user data and a real product catalog. I want to make online shopping easy again, and Vouch is a trust-first agentic way to do that. Thank you.
All right, the next is Kennedy School of Government and Harvey Mudd, which really clever people go there. All right, let's see what they got.
Hi, my name is Crisia.
My name is Lucas.
And together we build Poppy, the first multi-agent edtech platform. Nowadays, there are 1.4 billion students without access to any AI tailoring or tutoring platform, and teachers cannot tailor any of these platforms because they are locked in commercial models. Therefore, with Poppy, we separated the teaching with the LLM model and built it for all.
And so we have one platform and 3 personas. So for the student gets a personal AI tutor, which personalizes to their interests and to their learning style. Then the agents, they can communicate with each other for the class tips and class projects. And every student gets a dashboard to track their progress. But what is most interesting is the students keep that knowledge as they move from school to university and to the workplace. And what makes it all work is the open platform AI standard, which is basically separating what and how to teach from which models to use. So it's model agnostic by design. And the educator, using the wizard, effortlessly crafts the pedagogy, connects to the class, and then the YAML file is created.
And underneath it all, we have a Poppy Soul, which is this is a platform we're building and a protocol for safety, together with the Berman Klein Center of the Harvard Law School. So we added like ethical and human rights protection. And we can just see a little bit of the demo. This is how you enter Poppy. The teacher personalizes what type of agent they want. You can see at the right just the YAML to see how the agent is interacting, but in the real platform you won't have it. You can personalize avatar, choose your voice, and then that's where the teaching starts with what the teacher encoded. If you show signs of frustration, thanks to the Poppy Soul, it tells you like, okay, how can we change it? And then these are the dashboards of the teachers. This is how the agent-to-agent network connects to each other for students. Like, hey, what's your homework? What did you learn? Dashboard of the teacher as well to see what students are learning, where are they trapped, and the parent dashboard. You can learn more about Poppy later. Thank you.
Thank you very much.
Great. So, yeah, pass it down. So someone who's in the audience just came up to me, longtime friend, major player in the Boston economy, and he said to me, you know, there's the Boston Chamber, and they all sit around and talk about stuff, but this is where the real future power is. It's not in the Chamber of Commerce, which is very important, but it's these young Turks that you know, think they can do anything, and they're making these things happen. So 2 more young Turks, Graduate School of Design, represent.
Hello everyone, I'm Rain.
I'm Cici.
Many users want multi-agent collaboration, but today it still feels developer first. It's hard to understand the process, choose the right agent, trust them, and manage the collaboration. But CKC abstract that complexity away. Giving any task, it finds the agent, builds a team, assigns the work, and keeps human in control, making multi-agent work without code.
Most agent systems rely on predefined
Users
agents.
don't need.
But CKC takes another hybrid approach. We first analyze the text, and then we try to call the right agent. If the agent exists, we will call it based on the capability, reliability, and cost. If not, we will create a reusable new agent for the text with skills, heartbeat, and memory. Here's how it looks like in practice.
Users don't need to learn systems. They just describe what they want. CKC understands the task and decides how to execute it. It selects the right agents and plans the execution automatically. Every task runs with clear decisions. and full budget awareness. Once confirmed, execution happens, from data extraction to structured results. But it doesn't stop there. Every task becomes multiple reusable agents. Agents can be shared, reused, and even transferred across users. And over time, the system keeps working, detecting changes, updating results, without requiring you to come back. You don't run tasks anymore. They run themselves.
Yeah, so today people operate AI system, but we believe in the future you just need to simply express your intent. You don't run tasks anymore, they run themselves. Thank you.
Thank you.
Great. All right, I'm excited for this next team. We got a PhD in brain and cognitive science from MIT, and then he found two designers to complement his vision from Harvard. So brain and cognitive, who's not a brain and cognitive design, brain and cognitive science PhD, who's not? All right, well he is. All right, go.
Okay, hi everyone, my name is Kwai. You know about universal remotes, I absolutely love them. The annoying part was always setting them up, you know, looking for codes for your TV or for every device you want to connect them to. Now the good ones, they have this auto scan feature that automatically connects to your television. Think of Octopus as auto scan, but for AI agents controlling hardware, especially embedded system devices. Every appliance, every sensor, every robot arm should be controllable by an AI agent, but hardware doesn't ship. Hardware doesn't ship agent callable APIs. Drivers get written one device at a time, and the MCP explosion really hasn't hit hardware yet. So here's what that actually looks like.
Drop one shell command on a Mac, on a Raspberry Pi. The same 5 markdown specs hand a coding agent your hardware, and it writes the MCP server itself. Coding agents are the new operating system. Prompts are the instruction set. Claude Desktop picks up the Pi's public tunnel, sees the new tools, and starts calling them. The arm moves. The camera sees what it just did. Closed-loop visual motor control over standard MCP. And the only custom thing in the loop is Markdown.
So there are really two ideas behind this. First, the idea is that coding agents are the new software or the new operating system. You don't really need to ship code anymore. You ship instruction sets. So you ship really markdown specs, and the coding agent reads at install time and figures out what it needs to do to infect and deploy your hardware. Second is that prompts are the new infrastructure. So the same specs, the same goal is given to any machine, and one install command 20 minutes later, and you have a deployed hardware anywhere. So on our next slide, I really enjoyed working with this team. Our website is open and live, and later today, you can use the website to interact with our robotic arm that we'll have set up for you. And where this goes is an agentic operating system for the physical world. So think of HTTP for hardware agents. So we're honest about where we went with this, and there are a lot of challenges that we had to face. But we're really excited for you to experience Octopus and deploy it on any of your devices.
So, yeah, great job. So give the mics to those guys. Yeah, so I asked someone who's familiar with all the projects which one you were most excited about, and it was that one, but I don't want to bias anyone. All right, come here. But, and I don't know if it was a credible source, just because they knew all of them. Maybe they got, I don't know, whatever. All right, yesterday she won the Media Lab Hackathon, U of T, Austin grad, and at Sloan Business School. And we're at the 60% mark, but again, it's not really clear because the last 6 are 1 minute. So we're actually at like 65, depending on how you count it. All right, go.
Do you know who's their largest IPO this year? Answer is SpaceX. That's why you come to the Moonshot. If you want to become the next SpaceX, come to talk to me afterwards. So essentially, Moonshot is an agentic system that negotiates price and for the private shares. So basically, I interview 50 VC and also private equities. They all have strong interest in engaging my platform because they are having the liquidity concern. They want to get rid of the lawyers, get rid of the brokers, and actually engage in our agentic system. So agentic system trading the private shares actually can solve the memory. We have the privacy, and then we actually build a platform, and we have a bid-ask strategy. So
Moonshot, an agentic way to buy or sell your private company shares. Step 1, create your agent. Set its name and its persona, like its negotiating style. In this case, a sophisticated trader who make big assumptions. Step 2, set up the trade. Enter the company you want to buy or sell. Additional information is for group discussion, and secret information is for private negotiations. And that's it. Your agent will do the rest. Step 3, your agent will enter the matching lounge, in this case, SpaceX. Your agent will discuss with other agents using basic information only. When two agents match the general terms, they will go into step 4 for private discussion. It will be a direct negotiation between two agents where secret information can be used. If the two agents cannot come to terms, they will go back to the lounge. If they do, it will go to step 5 for confirmation. This is where human in the loop for final approval and settlement. And finally, there is a skill file for you to host your own agent in the landing page along with the documentation.
When 12 trillion is hitting your 401 account, 1.5 trillion market opportunity in secondary market share. So this is me, and then 18 years portfolio manager. I just won the hackathon yesterday with the Media Lab, the future of the bank, and also bring my team to the Fidelity Investment to meet 40 a senior executive there to talk about private market shares. Thank you.
You were the winner yesterday, but everyone's a winner today. Here, give the mic. All right, a PhD in bioengineering and life sciences. Let's see what you got. All right, go.
Hi everyone, my name is Pat. I'm the CEO and founder of Escript BioAI, and we are currently building causal AI for drug discovery in aging, starting with knee osteoarthritis. And one of the problems that we are facing right now is threefold. Basically, we need to find the patient data for fine-tuning our foundation model and find drug targets, which is very time-consuming. And also, assess this data, whether it's good enough to move forward. And then as well, we want to be able to autonomize the fine-tuning of our foundation model to find us drug targets. We don't want our GPUs to be basically sitting idle. So basically, this last semester, I built an agentic platform to accelerate the pipeline at the company. So here you can see Chiron, which is our autonomous scout. So he searches Mondays and Fridays. He's connected to the relevant APIs, and he has an analyst and a critic pipeline. Once Chiron finds the omics data that could be relevant for your pipeline, it feeds it to ACEX, which is a 7-agent agentic hive that, think about it like a C-suite that is agentic. So basically evaluates the targets that he has found. It has hallucination defense, as well as a truth tribunal, which is 3 LLMs. And then once it has found the relevant targets that are important for our pipeline, then he feeds it to Atlas, which is another agent that actually controls our workstation or GPUs to autonomously do the fine-tuning of the foundational model. So here you can see nothing. So it seems like but basically, what I showed you before is basically what, is like an agentic hive, an agentic scout, and then an agent that controls our GPUs to autonomously fine-tune our foundational model, which is very time-consuming. So this is us right now. If you want to reach out to find out more, or you want to test the application, you can scan the QR code. Thank you very much.
All right, two Sloanies, they met in the program, and let's see if they get along. I don't know if you know this, but Alfred P. Sloan is the one who ran General Motors and really helped make the School of Management into a thing. And while Ford had all his colors in black, it came in any color as long as it was black. It was Sloan who said, no, we're going to do multiple color cars, and that was sort of a differentiator. So if you didn't know that, now you know. All right. Did you guys know that?
All right. But now we know. All right, good morning, everyone. I'm Carl. This is Yanis, and we've built Sub-Agent Relay. It's no secret that agents are being used for multiple tasks, and a very efficient framework is for an agent, an orchestrator agent, to spawn sub-agents to handle different tasks in parallel. However, today that framework is not very efficient. The parent doesn't give enough context to the children, and they have to go gather that context alone. And then the relay is also not efficient. They give back a prose answer and just saying that the task is complete without additional context. So that's why we've built Sub-Agent Relay.
Okay, so sub-agent relay tries to change a loose handoff between agents and turns it into a strict rule-based protocol. Instead of the parent actually giving out tasks and then hoping that the result will be clean, now it only waits for a structured response from the child. We have also made the handoff state visible, so we know each state of the work that we are doing, and we have also implemented logic to filter out late responses or duplicate answers. Now we go to the testing. We have done experiments, and we have seen that our relay is actually filtering out all late responses. By that, we mean that the parent starts generating answers before it has the context from the child, and then regenerates the answers when it has the child's response. We have eliminated this in our plugin, and we can understand that we are more reliable, and we have a structured output, and the only trade-off that we have is slight latency. Our goal is to scale up and go beyond OpenClaw plugin and make it as a plugin in Codex and Cloud Code. Thank you.
All right, more Sloan students. Let's go.
Thank you. Well, imagine an AI agent helping a founder launch a new product. It can for sure write a memo, prepare a great financial model, and even write a great deck. But when it comes to find specific and fresh data like prices, local prices, supplier availability, or customer signals, then it gets stuck, scraping the web, hallucinating, and even asking again for help for a human. Because the web were made for humans to read pages, not for agents to buy data. That's why we built DataX, an agent-native data marketplace, where agents can discover, evaluate, negotiate, and buy structured data sets. Why now? Well, basically because agents are moving from just answering questions to execute workflows.
And now let's quickly do a demo of our marketplace. As you can see in this specific example, the buyer agent offers a price for a data set, and then the seller agent makes a counter offer with another price. Then the buyer agent accepts the specific price and sends the payment. And now the seller agent needs to receive the payment and release the data set. And that's the last stage of the transaction. So we are the right team to explore this because we understand different SMB data workflows and marketplace dynamics. In the next several phases of the project, we are planning to focus on missing production pieces, such as integrating real agentic payments and marketplace arbitration. And then our plan is to test all of that with real SMB data and AI agents. And finally, quality and unique data is something that differentiates high-performing AI agent and workflows from poor-performing ones, and DataX is the marketplace to enable that. Thank you.
The next one is called Agent Army, but it's not about defense stuff. Come on down. And we're at the 75 mark, so if you're sad that we only have 25% left, sorry. If you're happy, okay.
Okay, hello everybody. Let me start by introducing my amazing friend and partner, Colin. My name is Omar. I am Mexican, and before coming to Sloan, I was working 11 years in my family manufacturing business, and I live in the very first hand all the troubles of running a manufacturing shop, which is mostly depending in manual labor. So after coming to Sloan, we take this amazing class and we learn about the AI studio and the agentic economy, and we said, this can be possible. There is something that we can do better, and that's why we decided to start Agents Army. I want to tell you to remember this number, and it's around 3 billion. And this is the idle capacity that shop owners spend quoting every single day jobs that most of them, they don't win. So we decided to start, someone here mentioned that an agent is like having an intern, and I couldn't be more agree, but it's like an intern on steroids. So we decided to start this very first agent called Foreman, and what he does is to receive all your emails and read it
in form of quotations, and then extract all the information, analyze it, and flag to the end user any problem. Every day, the manufacturing industry runs mostly on emails and 2D and PDF drawings, which has a lot of mistakes in them. So this basically saves a lot of time to the owner. Right now, our solution is being tested in one shop in Mexico, and the users love it. It's saving a lot of time. So the end vision of this, we decided to start by something real with this agent. The second level at scale will be to put eventually many other agents that will be able to communicate between them. And the winning idea is to create the first protocol of a small manufacturing business talking to each other and creating and automating the world with what we see today. So thank you. Join us, agentsarmy.ai. See you there.
Yep, so now that we're at the 75% mark, I'm just gonna make you think, who has no idea what that sound is? Who knows exactly what that sound is? All right, Star Trek, the original series. If you know your Star Trek, the movie, The Wrath of Khan, the #2, that happens 250 years supposedly from right now. As the United States is turning 250, realize that that's like, we're at the midpoint. Who thinks Star Trek got it right? And totally is not right, that some of that technology is happening sooner and happened yesterday. Yeah, it got it right? Totally wrong. Or to be determined. All right, let's see. We got our next group, e-commerce savants doing agents plus e-commerce. Let's see what they got. Go.
Thank you. Agents doing the shopping for us is no longer a myth. It's already $1 billion industry, and in the next 5 years, it's going to reach more than $60 billion. But the issue is, when a mistake happens, when a wrong meal is ordered, when a wrong flight ticket is booked, whose fault it is? For that, right now, there is no accountability layer, no audit trail, no standard, no protocol. And the existing rules engines cannot solve this problem. That's why we need an agentic system to be able to solve that. Because agentic systems would have multiple features ranging from natural language interpretation to dynamic policy application. With this in mind, we are building Arbiter. When a dispute happens, you just send it to the system. And once you send it to the system, it just analyzes the dispute, and it then decides the fault is on the human, or on the merchant, or on the agent.
All right. So basically, this is similar to what Plate is, and it's Plate for AI agentic transactions. It sits like a neutral infrastructure layer between the agents, the user who makes the purchase, the merchant, and the payment systems. Then the first thing that it will provide is a dispute resolution, analyzing the intent, and then offering a full traceability on what happened along the chain of the transaction. And eventually, once it has enough data, it can offer a pre-transaction risk to the user making the call. Next slide. And how this will work ultimately is with a few agents working together and an arbiter accountability layer putting it all in one and synthesizing for results. So we have a user agent looking at the prompting, the intention, a merchant agent that knows the policies of each merchant that we're doing the transaction, and the payment system that's being activated. And all that sits with an arbiter, what we call an accountability layer agent that looks at the full log interaction and traces back with the intent chain to assign a liability across the party that it's at fault when the transaction happened. So to wrap up, we know that agentic transaction is going to happen. We know it's scaling up. We know Perplexity, Target, Amazon, they're all testing their products, but we don't know exactly how to do when things go wrong. And we're offering that solution for now. Thank you.
All right, just before we do that here, so a year ago, you were up on this stage and you presented, and did it all go downhill after that, or did it get good?
It got a lot better and good. So congratulations to all of you guys presenting here today. It's awesome. I got momentum. We took some pivots, found a co-founder. We are doing great, I would say. So yes, if you have any questions, please come talk to me.
And Abhishek too, here, stand up. Yeah, let's give him a round of applause. So there's a future after today. Just want you to know, people go on and do great things. All right, graduate school design, let's see what you got.
Trust runs on beautiful receipts. Bookty makes capability verifiable.
The job market runs on guesses. I'm at Harvard, and like everyone in my cohort, I have the trouble of showcasing my capabilities and the artifacts that I built this year. And I've talked to a lot of recruiters, and they have similar problem. They see a lot of AI-generated resumes, and they cannot parse through all of them, and they cannot ensure that the right person has the right capabilities. Bookty bridges that. Bookty ingests all your artifacts, research paper, GitHub repos, gives you a score, and publish it in a machine-readable and API-first module. And it's also beautiful. It's open methodology, everything is open-weighted. Every weight and threshold is published at Bookty.ai/wiki. And it's crosswalked with skills taxonomy used in the EU and in the US. No black box. So here's a very short demo. It's like any other vibe coding platform. You tell the design, and then you upload your artifacts, and it will ingest. Bookty will ingest everything and show it in a dashboard. Everything is beautifully designed, and you can edit however you want it. And, like I told you, it's queryable by OpenClaw agents, or, matter of fact, any type of agents. And you can look for, say, Learning Analytics Designer, specifically in the Cambridge area. Pilot is now live at Harvard GSC. Thank you.
All right, the next one is a great team that's using a social network to act for you in the background. You know, we're all going to have agents doing stuff as we're sleeping. Let's hear what they're doing with this concept. All right, go.
Professional networks are passive. You walk into a room of 500 people, you meet 8. The system already knows who you should meet, but it just doesn't act. It could meet hundreds of people. It could meet continuously and evaluate them. We fixed that. Here's how it works.
Yumoja transforms your networking experience into a continuous, intelligent connection system. Every user runs as an agent. When you join an event, our system continuously scores who you should meet and why, based on what you're building, what you need, and who's in the room with you. You type "pair me" on Telegram. Yumoja returns ranked matches with context, like this recruiter is looking for the exact role that you're looking for. This founder has a distribution partner you've been needing. And after the event, Yumoja keeps interacting with you and keeps remembering your facts and keep working on the background to make sure you keep the relationship going.
We ran this as a beta in MIT, Berkeley, and Harvard communities, and they loved it. We had over 300 live agents. Events are our starting point, not our ceilings. Think conferences, corporate offsite, Slack communities, anywhere where you need to meet people and you're not sure who. Professional networking is a $40 billion market, and the networking and connection layer is yet to be fixed. And that's what we're doing today. A network that is active, always with you, talks to you, and helps you connect. Yumoja.
Thank you.
Great. All right, so the next 3 are finance people. I don't think they left finance because they thought their jobs were going to be AI'd, but they're trying to bring private wealth to everyone. So AI plus finance. Come on down. Oh, by the way, I have 2 cameras. If anyone's bored and wants to photograph, just come get me. I want the cameras back, though.
Yeah. Hey, everyone. We're Lumen, and we're building this multi-agent platform that help retail traders to make better trades and grow their wealth. Making money from a single trade is easy, but keeping making money all the time and every day is hard. It's a constant process of iteration, revisions that require a lot of people to do a lot of research. And traditionally, these services is only being kept in hedge funds and asset managers. And the harsh truth is that if you go to a hedge fund and say, I want to deposit money, and the money amount is like less than 1 million, they're probably not even going to take your money. And currently, we see more than 100 million US retail traders been facing that problems, doesn't have the professional ability to make better trades, and they're relying on YouTube videos and tweets and gut feeling to make trades, and we want to make the change.
Okay, so what we want is to make investing accessible to everyone. And so our platform starts by asking questions to understand the user. So to understand the risk tolerance of the user, the investment style, the goal. And then it builds a personalized strategy. This strategy is monitored 24/7 and it's rebalanced accordingly. And most importantly, it's completely transparent, so it explains everything to the user. What's good about our platform is that it's based on a specialized agent and not one big model. And so we have like a PM, a data scientist, analyst, risk manager, and they all coordinate through a shared graph. And they can readjust their plan depending on the new information that comes in. And at the end, everything goes through the risk manager to make sure that it aligns with the risk tolerance of the user. And our platform also offers to connect directly to your broker account, and so you can make trades directly and get direct feedback and of your performance.
And here you can see our demo. So basically, you can choose your strategy. Then a team is assembled. The lead agent distributes the task to your agents, which have consistent memory across runs and can learn. Oh, the timer is up. Anyways, this is our beautiful demo. Give us hints, please.
Great. All right. So if you could hold up one hand, we have 5 more 2-minute presentations. Hold up the other hand. We have 4 1-minute. So we're down to our last 9. Our next speaker is a software engineer. I asked him if he thought the industry was changing. He said yes. And let's see what he has to say.
All right, hi everyone. My name is Matthew. I'm building Bastion, which is the trust layer for AI agents. We've heard great presentations today, great ideas, but I want to take a step back and see how safe are we deploying these agents? Like, can we really deploy them at scale without fully controlling what they're doing? The answer is no. Enterprise don't fully trust agents yet, so they have to find a way to deploy them and control what they're doing. So they need access control, and they can't just prompt it to make no mistake. It's not gonna work. They need a way to give agents different policies and permissions to do different tasks. And so the solution is very simple. We're building a layer on top of every tool call for AI agents so they don't mess up. And the first layer would be the code policy, which is very simple, like a straightforward way to limit an agent. Say, for example, it can only do transactions that are maximum $10. But the thing is, we need to identify intent-based policies, like why are they doing this? And so there's an LLM judge that's checking, okay, is this agent like buying office supplies, or is it more just buying PlayStation 5s for all the employees? And then the third level is a human in the loop, because at the end of the day, as much as we want AI agents to be fully autonomous, they have to answer to their boss, which are humans, I hope. And so the way we're doing this, while for every tool request, we're controlling what the agent is doing, making sure it's allowed to do things. At the same time, we store that information in an audit trail, which is encrypted. So at any point where at that audit trail, if it's tampered with, it's gonna detect any tampered, so it's compliant with enterprise, basically.
Yeah, great. All right. As you know, I'm wearing a lobster claw on my tie. The next one is Clawnection. We're down to our last 12 minutes of presentation. Go get them.
Hi, everyone. Hi, everyone. I'm Dimitri, and this is Clawnection. The problem is very simple. Dating apps are notoriously time-consuming, expensive, and usually disappointing. Most people who interact with them would agree, and it's a problem that we need to solve. So I asked a very simple question. What if your AI agents could just go on dates for you? So the way Clawnection works is users create a dating profile using text inputs and by having a short voice consultation with a VAPI AI agent, and also by uploading examples of their text communication like a WhatsApp export. From there, we built skills so that their personal agent can learn who they are, what they're looking for, and ultimately how they communicate. So from there, their personal agent searches our database for potential compatible matches. When they find one, they invite that user's agent to actually go on a short virtual mini date. Each user's agent ranks or rates that interaction, and if both rank highly, a mutual match recommendation is pushed to the users to encourage them to actually meet in person. Oops, excuse me. This is an example of it. I'll explain the architecture later, but what you're looking at basically is a post-profile creation loop. So you're seeing the agent discovery, finding the agent, inviting them to a date, and then now the conversation's occurring where they're actually interacting on the basis of what they know about each of their respective agents. At the very bottom, you'll see a verdict is rendered. So we rank them, or we score them 1 to 10. If it's a 7 or above on both sides, that's the mutual match. So we're not trying to replicate, or not trying to, we recognize human chemistry is very important, but the problem we're trying to solve is to reduce the time and wasted energy that we all spend trying to find meaningful connections, whether it's in a romantic context or not. And if you want to learn more, come meet me after. Thanks.
All right, the next one is Mycelium. His co-founder, PhD from MIT, is in Germany right now. So I think she may be presenting there, so they're they're very efficient. But Harvard Kennedy School, Mycelium.
Thanks. Hi, I'm Mo, and together with my co-founder Marlene, who's in Germany right now, we're real nerds about silos. But not these silos. We are not a fertilizer startup, knowledge silos. And anyone working in any large organization knows that's a big problem. Just the Fortune 500 are estimated to lose 30 billion to them. That's why we're building Mycelium, a solution inspired by nature. Mycelium networks route nutrients and information not to where they're already concentrated, but to where they're needed most, ensuring the survival of the whole organism. Thanks to the advent of agents, a decentralized structure like this is also possible for organizations. That's why we built Mycelium, a read-only layer that measures where knowledge actually creates impact and routes it where it matters most. Just like a mushroom network, it wraps around your existing infrastructure and connects it to your team's agents. How do we measure where impact is created? We use Shapley value attribution to only route it where the highest marginal effect is likely to be, and all of this is recorded and audible in a credit system. Well, does it actually work? We ran simulations where we could prove that we could capture 88% of the information value, filter out all the noise, and create counterfactual impact that humans would not have found. We're already working with 2 design partners on this, and to show you how this looks like in practice, we have a short demo. Basically, you can see we select a scenario, you have agents that then get access to information, send them to other agents, and each of them evaluates how much impact a given document, creates for them. In this scenario, a company discovers that a bug that's reported in a customer complaint is immediately forwarded to the engineering team so they can work on the bug when otherwise it would have sat in some email. We can finally show you the information in our demo. This is us. This link goes to our webpage. Thank you very much.
Great. All right. So at 12:15, 240 pizza slices are being delivered. I hope you didn't come just for the pizza. Okay, 12:15 pizza. All right, John Perry Barlow. Who knows who that is? Okay, of course you know. Okay. So his daughter is your girlfriend, right? Yeah, one of the founders of the internet and big Grateful Dead fan. So if you want to learn what the past was like, talk to Carson up there. He's in from San Francisco, flew in to hear this. So, everyone's like, oh, people are going that way, but people are also coming this way for our things. All right, go tell them what you're about.
Test, can you, yeah, everyone can hear me. Hello everyone, my name is Eli, very excited to be in front of you here. So when you develop things, before LLMs, you all went to Stack Overflow to try to debug your codes. Took a lot of time. Many people here can relate, I think. I do. That's why now, when the LLM just got invented and existed, it redefined totally and completely the way to code and to develop your platforms. That's why now, when we have all our agents, now you can also ask and tell your agents to code for yourself, but when they find errors, they have to come back to you, which I think is a huge problem, and that's what I faced when using my agents. So what we're building here is a Stack Overflow for agents, kind of plugging them like an MCP server, where they have access to functions, and they know how to use them in order to solve their bugs and to debug their code. That's how it works. So basically, if they found an error in their code, they search for it on the server. If they don't find the question, they pose the questions. Other agents can answer it with a reward system, and all the answers have been verified by other agents to create trust among all of them. So basically, here is a platform where agents are the users, not the humans, so that we can minimize the interactions between us and our agents to code whenever we need. So there are 6 tools we can use for our agents here, which is the search thing, where the agents can search how to debug their code on the platform. You can look at it. It's called Debug.dev on the internet. They can get questions, they can pose questions, they can post answers, and they can verify answers, which get them to increase their score. Let's look, for example, at the demonstration here. So it's 2-step to connect. You can connect via GitHub or Google to connect with your API keys, deal with it, and at the end of the process, your agents will be able to pose questions when they find a bug and to be debugged by other agents. So it's kind of creating a knowledge database for all the agents, which will be the next Stack Overflow. Thank you very much, everyone.
Thank you. So yeah, give the clip. So you see Caden right there holding that carbon monopod. Caden is one of the most decorated lacrosse players in the history of the sport. He scored more goals than you can imagine. There's life after lacrosse. See, he's really good at doing the photos. I want to thank all the people with cameras who are documenting today. He's also a big finance nerd. All right, masters in data at MIT. This is the last 2-minute presentation. The next are going to go really fast, 1 minute at a time. Go.
Hello everyone. So my name is Indy, and this is Bernardo, and we're building AI agents for operations research. So what is this? First of all, most teams today run their business operations on spreadsheets. They know they could act over it, but they don't know exactly why and how. So this is where we come into play. But let's dive into a real example. Hi Bernardo, how are you?
How about you?
Good, good.
So my reality nowadays is I have one store. Every day we get about 6 orders. There's about 6 time windows for each of these orders. We have 2 motorcycles to help us out with the deliveries. But what happens is we have 1 motorcycle going to the order, coming back to the store. Next order, back to the store. There must be a more efficient way to go about this.
For sure, Bernardo. So if we sum up your problem, what it looks like is that you manage a store, you have orders sitting at your stores, you have delivery drivers, but you don't know exactly how to ship this in a way that is going to minimize your cost and optimally. What if I told you that you could convert all this text into this math?
That would be amazing.
Well, yes, sure. And if you solve this math problem, what you get is this as a solution. This is what you're doing on the left. This is suboptimal. You can see the cost up there. And on the right is the optimal solution to the formal mathematical problem that you just saw before. So again, you'll tell me.
I mean, but I don't know anything about math. How can I go from this to that?
Yeah, how do you go from this to this? Well, this is where we come into play. This is Opera, this is the platform. You can input your problem as English, your data sets, and a swarm of agents in the backend. This is based on a lot of research that is being booming in the field of AI operations research. We'll tell you what's the optimal solution to your problem, what decisions you can take, which delivery drivers to send where, etc. And this in no time.
But are we building something that people actually want? We tried out our first pilot in Brazil. We saw 30% reduction in cost with the exact example that we presented you guys. We're active in 3 other pilots, different areas of optimization, but very promising results. We'd love to hear some feedback from you. Thank you.
Thank you very much.
All right, yeah, okay. So, all right, so you may, this is gonna be 1 minute. This kid's a mechanical engineer, course 2, and he's a senior at MIT, and he's in Ramesh's lab. You may be saying, well, what's a mechanical engineer doing in Ramesh's lab? Ramesh's lab, he wants to be at the forefront of robotics, and he thinks there's a Venn diagram there. So he's smarter than all of us. He knows what he's doing. He's got it all figured out. Let's hear what he has to say for only 1 minute.
Hi everyone, I'm Luke. I'm introducing Lattis, an agentic pipeline for automating the design of your perception stack. So all robots have some notion of seeing the world, and they accomplish this in different ways depending on their specific task. And typically it takes a team of engineers 12 months, 36 months, a long time to design their perception stack. But with Lattis, we can automate the sensor selection process and the iteration process and cut that time down significantly. So how do we do this? We build every possible sensor from 15 basic physics capabilities, and that gives us upwards of 33,000 sensors, most of which have never been constructed. Now, depending on your task, an agent searches that space and finds optimal clusters of sensors that would work well. From there, another agent actually builds a frontier showing different sensor trade-offs between cost and capacity. Now, this isn't to say one sensor is better than the other. This is an informed business decision you get to make. So you can see how Tesla and Waymo perform differently. This is the agentic output, tracking a basketball outside and counting people in a room using 2 different sensors. Thank you.
All right, don't be alarmed. These are 1 minute. All right, guy went to Parsons. He's a design engineer at Harvard. Go!
Hello. Everyone is building AI agents, but Zeni is building what AI agents need. I need that. Zeni is building what AI agents need. So currently, with agentic systems, you need to tell the agent everything what it has to do, and the agents will perform. But in this case, agents will actually communicate with each other and complete the task for you without checking in. It's built on zero trust, so the agents won't automatically assume that the work is good. Everything is based off of what the human recognizes as the standard for what they need for their task. So Zeni adopts the accelerating faster than shared infrastructure. So most people are building the AI agent systems, but the infrastructure is a critical component of that AI system. So in order for this to work, you need to actually build both. So Zeni acts as a hub, where Pitstop is the human-facing component, and SideQuest is the infrastructure for everything. So it's one governed pipeline with the operator intent to execute the user task, and that's Zeni. Thank you. Okay. Yes.
All right, so we heard a lot from the graduate school design. Now we're going to hear from the MIT architect students. Let's see if they're similar or different. Ready? Go!
Hi. Hi, people. We're the team of Rosita, and we know that modern apps were mostly made for human eyes, but what if we can have agent to work on those apps? And since it's non-AI native, it probably don't have API, but we can try to have the agent learn from past agents who have explored the very same apps before, because to do that again was basically like based on vision, and it burns tokens. So we're building this protocol as Rosita to have AI learn from all those other agents that have done the very task on the very same app before.
So Rosetta is built and self-regulated by user and also explorer agents while preventing prompt injection and also leakage. So to use Rosetta, simply install the Rosetta MCP. Next slide. Simply install the Rosetta MCP, and your agent will automatically look up for the most effective strategy for your task. So you don't have to install plugins specific to your software. You can also give your agent a budget, and also to discover app, verifies them to contribute. So in this demo, can we go back a little bit? Sorry. So in this demo here, I'll give Claude a complex task in Photoshop. So what Rosetta brings is not just shortcuts, but also an approach. For example, while the video is not playing, So comparing with traditional methods is much, you could execute like complex tasks in a fraction of time and token with a much higher reliability. So come use Rosetta and we can make every app agentic. Thank you all very much.
Great. All right. So these are 40. I don't know how many people can't even count to 47. But this is our 47th presentation. Ladies and gentlemen, an economist and a computer science guy. It's like an economist and a computer scientist walk into a bar.
Hi all. At NAT, we believe that in order to train AI to predict the future, the best way is to teach it from the past. So think about it. Every major single technological breakthrough in the history of humanity left some traces. The 1947 wire story was buried in a page 11, was the single most important innovation of the century. mRNA papers were dismissed as non-important for 2 decades. Nobody read the signals, but we have. We have a human researchers teams from Harvard, Stanford, and MIT to read thousands of articles and label them in hindsight. And that means that, we have all these articles, and that means that they're reading in hindsight, yes.
Hundreds of thousands of rows of these labeled articles, millions by month's end, and no one is training on hindsight. So then come the agents. They read every patent, every preprint, every procurement filing as soon as it goes public, and our model flags the small signals that looks like the start of something big.
Companies will tell you, for example, that a missile was tested yesterday. NAT will flag the proportional technology 3 years in advance. So it's the same product, but in 3 years a head start. And that gap is the product. Thank you.
All right. Who has Gmail? Okay, this guy used to work at Gmail at Google, and he's at Harvard now, but he has MIT envy, so he's wearing an MIT shirt. No, I tricked you. He's an MIT guy. All right, let's see what you got.
Right. By quick show of hands, how many of you here want your agents to make money for you on the market? Keep your hands up. Keep your hands up. How many of you are willing to trust your agents with real money without any proof of performance? Okay, only one person, a few brave souls. So we are 2 broke grad students with deep scars of losing money on the stock market. And we built Polyclaw, a playground for agents to invest on real bets on Poly market, but with fake money. You can spawn any number of agents, testing any number of strategies on real Poly market bets and see what's working and what's not. You can get a leaderboard of how your agents are performing and backtest your strategies on historic data and then approve real trade requests right from the platform. So if you want to build the future of personal investing, then come join Polyclaw. Thank you.
All right, so don't be alarmed. You saw Snigna before. She didn't sneak back in the line to present a second time, okay? The team that's supposed to present right now is in London trying to get customers for their medical layer thing, and she has offered to present. So if you recognize her from before, that's because it is her. But this is a different presentation. Good luck.
So Minerva is building the intelligence layer for medical records. So as you can see, I'm not up on the slides because the team have left their very high-paying finance careers to go and try and get customers today. So the problem with medical records is it's very difficult to parse through above like 10,000. The whole process takes about 1 month, and with Minerva, the process takes 10 minutes. In the interest of time, I will take us.
Hey guys, just going to give you a quick overview of Minerva. So here you can upload your medical records just for the sake of efficiency. I've already uploaded them. The agentic OCR and the semantic extractions happened. Once that happens, you can go ahead and review them. And as you can see, this is an entire bundle of medical records. And it's been categorized using categories the user has specified in the settings. And these can be changed along with the dates. And what happens when you change them is it creates a labeled data set, a labeled correction data set for future accuracy. Thanks.
All right, thank you.
All right. That was our final presentation. I just want you to know, in a moment, we're going to have all the judges come up. This is a very special photo. One time we had a big head of Ramesh, and so it was a big Ramesh and then all of us. We're not going to do that one, but folks in the back, maybe get ready for that. So judges, get ready for your good side. We want to celebrate it. And then we want all the teams up here too, and we want to make a statement that this is not only the best demo day. Someone said to me, "Oh, this is so much better than anything I've ever been to. This is awesome." We want to make a statement. This is the best demo day in the galaxy, and we'll get you that image. And if you liked it, you can do social stuff with it. So anyone with the 6 cameras that are out there, please get ready. We're going to do a group photo, 2 of them. I want to invite Ramesh up. Ramesh, this is the, I think, longest entrepreneur class. And Ramesh is really proud that it's not teaching entrepreneurship, the basics. It's teaching people how to build things that have impact and that have meaning. And this class has come so far. Partly the world has changed and the kind of tools, which Ramesh was talking about like 5 years ago, saying this is going to happen when no one else was talking about this. A lot of the top AI experts were saying what's happening now was 90 years away. Their kids, would use that technology. And not Ramesh, he was saying, John, it's coming. And it's came, and now we're doing something about it. Ramesh, why don't you put some closure and help people understand what we just experienced?
Yeah, first of all, big congratulations to the 48 teams.
Did you say 48, 49?
Yes, those of you are counting. But it's really amazing, what we can do. Always try to remind everybody that, the world GDP is about $100 trillion, out of which only about $5 trillion is IT and software. And those of you worried about, be eating up the software jobs and displacement within software industry, the remaining $95 trillion, the real world economy, is also going to be impacted with AI agents. Not with AI, but with AI agents. There'll be digital, there'll be in the physical world, and so on. And this is the moment of how we're going to bring, a lot of prosperity, a lot of social justice, a lot of democratization into the real world, because we're enabling and reducing the friction of delivering those services. And I would like today when MIT graduates graduate, or Harvard, there's like, oh, I want to go and work in finance or software and things like that. But I hope that in a few years from now, they'll say, I want to go work in water, or I want to work in, wastewater management, or I want to work in health. Sectors that have 1 or 2% margins, or almost negative margins right now, will probably have 20, 30, 60% margins going forward. So that's the dream, that we will be able to build that. But we need all your help. As I said, we have about 250 plus students who want to come and work on this, but it can only take about 80. So we need all your help to see how
we're limited by the number of seats in the room.
Exactly, right?
That's such a lame limiting factor.
But we can run this in bigger rooms, but we need more instructors, we need more compute, we need a lot of mentorship and so on. So if any one of you can help us scale this, we won't do it 2x, but over the years we can do it 2x or even 3x of where we are. So anybody who can sponsor the course, or send your engineers to be mentors, or send your expertise to be here, sponsor compute, and so on. So we need a lot of sponsorship to make this happen.
Do you want them to sell their luxury car?
Yeah, I don't think that's necessary anyway.
Yeah. No, but I think what Ramesh is saying, that he is a talent magnet. You saw that today, and he's saying that he has cycles to expand this. And I've seen this at Stanford and some other universities that I do a lot of work with. A lot of the faculty are spending more and more time outside the school taking advantage of this moment. And I think what I just heard from Ramesh is he wants to double down on this. And I'm really proud of him for being so committed to the students in this work. And if any of you want to help scale it and you have access to resources, maybe it's creative resources, it's not just selling your car, it sounds like he's open for business.
Absolutely. So that's on the course side, the AI Studio course, thank you. And then in parallel, there's something amazing happening, which is how are we going to keep the agentic web open and neutral? Very inspired by Tim Berners-Lee, how we set up World Wide Web Consortium, and that's why we have an open and neutral agentic web, which we did not get in social media.
That's a profound point. Tim Berners-Lee, who we've had dinner with and talked about this, he could have exploited that technology and tried to make a lot of money. And when the Olympics in London, I think 2012 happened, they celebrated him. They were celebrating him for creating something. Web 2, there's been some, challenges with privacy and stuff, but it's an open thing that the world had access to, and you have a vision similar for this moment of technology.
Absolutely, absolutely. And I think there's a moment here that it could, the World Wide Web could inspire the agentic web. An agentic web could potentially look like an open, neutral, and safe and scalable platform for all the 48, 49 teams that you saw, and everybody else could build something. Or it could end up becoming more like Facebook, Twitter, and iOS and Android, highly, walled gardens, closed ecosystems, which are good in their own way, but also stifles innovation. And there is unfortunately a risk that over the next year or two, the whole agent stores, agentic ecosystems could be—
Adam, you're going to miss the group photo. Sorry.
It could be controlled by one, maybe two players out there, and they own the whole stack, from chips to cloud, to agent stores, to dependencies, tools, and everything like that. And unfortunately, a lot of innovation, a lot of research, a lot of investor money, a lot of startups, could all be gone in the next year or two if that's what happens. I think hopefully, again, agentic web looks more like the World Wide Web as opposed to what we see on iOS and on Android. And again, we need all of you to participate in that. So a small plug for our research here at nanda.media.mit.edu. So please join that. And we also have an open source effort called Project Nanda, projectnanda.org. So if you want to participate in any of this aspect, the course, the research, the open source, please join us. Go to nanda.media.mit.edu. And let me bring it on Nikolai, who's been an amazing leader here for the course.
Woo! Yeah, thank you. I have almost nothing to add, but I want to reiterate and thank students who participate in this course. I know it was a very challenging course for most of you, and you put lots of hours in making it happen. And also, I want to thank the course team, especially Maria, who put more hours than any of the students. Thank you all for being here, and I hope you enjoyed.
Yeah, we should also thank Suzanne in the back, who's helping us with all the arrangement. Thank you, Suzanne. Nikhil, of course, who's already busy. Pradyumna, our postdoc, working on this. So a lot of people behind the scenes, but we need 3x more manpower to run this course if we're going to scale these efforts. So
yeah, so if you're a judge, come on up, and we're not going to filter. If you're a fake judge, we're not going to tackle you, but please, just the judges come up. We want to celebrate your work. And Nikolai, could you start collecting the sheets? So all the cameras, we're going to have 700 megapixels.
And then after this, we're going to invite all the teams to come on up after this picture.
And then if you have a question for the teams and you didn't get to ask, we encourage you to go find them after this session. And again, we have 240 slices of pizza. It's not a prime number, but it's enough pizzas, I think, slices. All right, so judges, no gang signs.
Let's be in the front. All right, where to squeeze?
So here, lacrosse guy, go in the center. Yeah, long pole. Okay, yeah, right there. All right, so get in the center. Yeah.
And then we'll have the scores for the teams very soon, in a few minutes, as they're being tallied.
All right, see the green light? Look at the green light. It won't hypnotize you and do a Jedi mind trick. Do it again. Yeah, you're doing great. Okay, so everyone look up. No one look down. You look silly. You didn't push it. I think you pushed the wrong button. Yeah, you got it. You're good. All right, everyone right there. Let's go. All right, now let's get the ginormous photo. If you were one of the teams, come on down. And if you were a team 2 years ago, you can come on down too. Yeah, all the teams. So 49 times. Yeah, all right. So I need someone to use this camera to do a photo. Here. Nice glasses. You're taking the photo.
We can pull some chairs. Feel free to pull some chairs.
Yeah. And someone in this photo is probably going to be ridiculously famous for what they created, and the rest of us can claim we were in that photo. So there you go.
John, take a chair. It's a little bit lower.
Okay. All right. Ramesh wants me in a chair.
Nikolai. Where's Nikolai? I am on the back. Okay, take a chair. You can sit here.
All right. So,
take a chair.
Yeah. All right.
Just make some space for Nikolai.
Yeah. And Cam, Kaden, you're getting the wide angle. You're getting everyone. Or is you may want to go back.
You learn to go back. Pictures for.
All right. Yeah. Kaden, go back. Do one more and maybe go back like 7 feet. Yeah. And go to your right by a foot. All right. Oh, nice. We'll give you photo credit. All right. On 3, agents are here. 1, 2, 3.
Agents are
here. All right. And on 3, go Nanda. 1, 2, 3.
Go Nanda.
All right, so I know everyone here is a winner, but a third of you will be super winners, a third of you will be medium winners, and a third of you will just be winners.